Today we're going to start talking about Chapter 2. We're finally going to learn about derivatives. I know I've mentioned them before, and we're going to be doing derivatives pretty much for the rest of this year because they have so many uses. Their three main uses are, first, the slope of a tangent line. Secondly, velocity of an object when given distance traveled. And thirdly, rate of change. Remember, these are not on your notes, so make sure you write them down. Memorize these. And know that at any point in time in these videos, you can pause them, write down what you need to write down, and then continue. Feel free to rewind, whatever it takes for you to get your notes filled out. F apostrophe A is really read F prime of A. And how do you find a derivative? Definition 2. We've been doing this for a section already. That is a derivative. You've already been finding them without even realizing it. Now, this was definition 1, and I mention it here because that is an equivalent way of stating the definition of a derivative. It would be the derivative at one specific point, but that's going to be falling by the wayside, and definition 1 is going to be the route we take because we can find multiple derivative values at different points with doing the algebra once rather than doing the whole process for each point that we want. So for the function at the right, let's arrange the following in increasing order. So 0 is 0. F prime of 2 is the slope at 2, and I didn't do a very good job on that, but the slope at 2 means the slope of the line. It's a positive value. F of 0 is negative infinity. We know this one's positive. This is just 0. F prime of 3 is the slope at 3, which also is a positive number, but it's a small positive. And they want these listed in increasing order. So which of these is going to be the smallest? F of 0. Next one will be F prime of 3 because it is a small positive number. Notice its slope is smaller than the slope at 2. Oh, scratch that. F of 0. What comes after negative infinity would be 0. Then F prime of 3. And then F prime of 2. In order from smallest to largest. When they ask for F prime, they want the slope of the tangent line at that point. So, find the equation of the tangent line at the point 3, 6. We're going to use definition 1 to find our equation for slope. Or definition 2. The limit as h approaches 0 of the difference quotient. We're going to need lots of space. So, I'm going to use x's this time. Doesn't really matter what you use. But we've got f of x plus h minus f of x all divided by h. Now, ideally, enough h's will cancel out in the top that our h in the bottom will cancel out. We get x squared plus 2xh plus h squared minus 8x minus 8h plus 9 minus x squared plus 8x minus 9. And all over h. So, at this point, my x squared cancel out, my 8x and my negative 8x cancel out, my 9 and my negative 9. Everything that I have left has an h in it, which means I can pull it out. So, once that h on the bottom cancels out like it just did, then I'm able to plug 0 in for h. So we got 2x plus 0 minus 8, or our equation for slope is 2x minus 8. Now, we want the equation of the tangent line at the point 3, negative 6. So I need to find my slope at 3, which means I'm going to plug in 3 and get my slope to be negative 2. So my slope at 3 is negative 2. My point is 3, negative 6. So y minus negative 6 equals negative 2 times x minus 3. We get y plus 6 equals negative 2x plus 6. Y y equals negative 2x when we subtract 6 from both sides. So our equation of our tangent line is y equals negative 2x. Now, sketch the graph of the function where function g, where g of 0 equals 0. Well, that's easy. I can plot that point. G prime of 0 equals 3. It means our slope is 3, so it's a pretty steep slope at that point. I'm just going to sketch that in. They tell us the slope at 1 is equal to 0, so when we get over here to 1, we're going to have a slope of 0, which is a horizontal line, and g prime of 2 is 1. So, what could our line look like? Keep in mind, your line may not look exactly like this as long as it meets those 4 criteria. So, it could do, there's one example. It could do all kinds of things. It could come up here, go back down, and then have a slope of 1. Lots of different possibilities, so keep in mind, I will just look at your graph and see if it meets the 4 criteria given. Now let's talk about some meanings. We already learned the 3 uses of a derivative are slope of a tangent line, velocity of an object when given distance, and rate of change. So, it says the quantity of ground gourmet coffee sold in pounds that is sold by a local coffee company at price $P per pound is Q equals F of P. So let's talk about this for a second. If we were to graph this, we'd have quantity sold based on P price. So let's talk about F prime of 8 and what it means. Well, F prime of 8 means not velocity, we're not throwing this coffee. It's not slope of a tangent line because that doesn't work in real world situations, so it must be rate of change. The meaning of F prime of 8 is the rate of change of the amount of coffee sold because that's our y value when coffee costs $8. Now, quantity is labeled in pounds, price is labeled in dollars, so the units for F prime of 8 is going to be pounds per dollars, and that's not really dollars, but it's dollars per pound. So it's the pounds sold per dollars per pound. Now, let's talk about B. Is F prime of 8 positive or negative? What is this graph going to look like? When coffee's cheap, how much are you going to sell? Probably a lot. What's going to happen as the price gets bigger? Because as we move this way on our graph, the price is getting higher, so we're going to be selling less and less depending on how high it costs. So your graph is going to look something like this. So, F prime of 8, which means the slope at 8, is that going to be positive or negative? Well, it's going to be negative because as the price goes up, less coffee, fix that, less coffee will sell. When price goes up, some people don't want to buy it. I'm not going to pay that much for coffee, so they don't buy it instead of buying it. So, this was just an understanding. Make sure you can wrap your head around what a derivative represents. You'll be glad you did, because when the AP test rolls around, there is a lot of labeling and describing and explaining your reasoning and justifying your answer, and all of that requires an understanding of a derivative.